Dr. Dickinson, and today I'm going to be talking about drawing math models Singapore style. So maybe you've heard about Singapore math before, or you're just getting started. In this video, I'm going to be walking you through the process of solving math problems using a bar model approach. And we're going to move through the progression of how that develops, starting with our first and second graders all the way up to middle school. Now, if you're going to be using this in your class, I would suggest starting with a grade lower than you are teaching. And again, my name is Dr. D. I'm a professor of teacher education at National University with a focus on elementary and middle school math. You can find me on my YouTube channel. Don't forget to like and subscribe, as well as my website, Teacher Prep Tech. If you want to see more about what I'm doing in the classroom, follow me on Instagram at Teacher Prep Tech. So we're going to be talking about bar modeling. And again, this comes from the Singapore math approach, where students begin by drawing a picture. And the picture is a bar model. This is a wonderful approach, starting with addition, subtraction, and then moving towards fractions, ratios, and proportions. You can see we're moving into middle school math. And most importantly, this is going to give your students a bridge to algebra. So we're really going from the concrete all the way to the abstract. I just want to highlight that there has been a ton of research out there on the Singapore math model. In fact, there's entire curriculum programs that are just on Singapore math. And it's wonderful to see that the research is showing this is a wonderful way to approach problem solving and as an alternative teaching style. Students have had really positive attitudes with using Singapore bar model, as well as it is a wonderful tool for students that are in need of remediation. So let's go ahead and take a look at it. Now, there is a step-by-step approach that I'm going to walk you through today. So you're going to hear me pausing, but certainly you can pause the video at any time to work out these problems together. If you've subscribed to the channel, you can get access to this entire presentation, whether you want to use it in a professional development with your teachers or to just work through the problems with your students. The first thing we're going to do is read each of the problems in the slides. Then I will ask you to rewrite the question. Of course, every problem has a question at the end, right? But we're going to rewrite it in a sentence form. We'll give a space for the answer. So think about having a closed sentence. You have blank space for your students to fill in an unknown. And that unknown is the answer. We'll then begin by determining who and what is involved in the problem, and we'll draw our unit bars. In step 5, we're going to chunk the problem by rereading, adjust the unit bars, and then fill in the question mark. The question mark is going to indicate what we're trying to figure out. Once we've identified what we're trying to figure out, we can go ahead and compute and solve the problem. Then once we've solved the problem, get to our final step, which is writing the answer and checking to see if it makes sense. Are you ready? Let's go. We're going to get started with the subtraction problem. This is a wonderful problem that you can use in your early elementary classes with your kiddos. Of course, it has Pokemon cards, but kids don't like Pokemon. So let's go ahead and do step 1, which is to read the problem and to picture what it's about. Then we're going to do step 2, which is to rewrite the question into a sentence. Jada has 45 Pokemon cards. Micah has 28. How many more Pokemon cards does Jada have than Micah? All right, we've read the problem. What's it about? It's about who has more Pokemon cards and how many more Pokemon cards does Jada have than Micah? So we'll go ahead and rewrite the question into a sentence. Jada has blank more Pokemon cards than Micah. All right, now that we have a question, we're going to go on to a statement. Remember, we're going to tell, not ask. We'll go on to step 3, and that is who and what is involved. It's Jada and Micah. Jada has 45 Pokemon cards. Micah has 28. Step 4, we're going to be asked to draw the unit bar. We're going to give each variable a separate unit bar in this situation because Jada has 45 of her own cards. Micah has 28. Now, in step 5, we're going to chunk the problem and adjust the unit bars. Again, we can reread the problem and we'll see that, Jada has more. So Jada's bar model is actually going to be bigger. and I'm trying to figure out how many more does Jada have than Micah. So we'll adjust our unit bars. Notice here that I've drawn a partition to indicate how much more that Jada has. And now I know where to put my question. I need to find the difference between Jada and Micah. And there we go. So our question, we can then go ahead and begin to solve the problem. You probably already identified that I need to find the difference between Jada and Micah. Your students might have several ways of solving this problem. We can use a number line, or we can use the subtraction algorithm, or we can count up from 28 to 45. So in this one example, the student had done 48 plus 2 and 28 plus 2. She wanted to get 30 to the whole number, and adding 2 makes the equation the same distance. So the distance between 30 and 47 is 17. Let's look at another way a student could have solved the problem. 45 minus 28, again adding 2 to 28 to make it 30, and 30 plus 15 would be 45, and 15 plus 2 is 17. So adding up from 28 to 45. Of course, you could use the standard algorithm, but in that situation, you would need to regroup. And maybe your students haven't learned the algorithm just yet. That's okay. If your students are stuck, you can always use counters, or you can use a number line to help your students find the difference or the distance between 45 and 28. All right, now that we've answered our question, Jada has 17 more Pokemon cards than Mika. That makes sense. We did it. Awesome! All right, friends. Here's a great question to ask about fractions. This one actually involves mixed operations. Kat received $48 in birthday money. She put half of her money into savings and spent 3/4 of the remaining money shopping at the mall. How much money does Kat have left? Step 1, we read the problem. Step 2, we're going to rewrite the question into a sentence. Go ahead and do that. All right, you might have said Kat has blank left. Great. So now that we know that what we're looking for, how much money she has left, we can go ahead and move to step 3. Who and what is involved? You got it. It's Kat and her money, right? And then we're going to draw the unit bar. So it's all Kat's money. We'll just draw one unit bar. And we might ask our students, does this amount represent part of her birthday money or all of her birthday money? You got it. It represents all of her birthday money. So we need to go ahead and chunk the problem by thinking about the information that we have. And then we'll adjust the unit bars and fill in the question mark. So Kat's money, she has 48. She puts half of her money into savings. So we can go ahead and illustrate that in our bar model. You got it. We'll just draw a partition there to show half of her money. And then what happens in our problem is we have to see what is remaining, right? Because we want to know Kat has blank money left. That's her question. She spent part of her money at the mall. So we can draw another bar model to represent that part. And that is how much she spent at the mall. She spent 3/4 of her money at the mall. How much is left? All right, let's go ahead and compute and solve the problem. If you want to pause the video, go ahead and do that. All right, so now that we have thought about ways that we can approach problem solving and we have a visual to help us work through that process, don't forget, it's okay to make mistakes. And through the process, we can learn different strategies. $48 represents the amount of money Kat received for her birthday. Half of 48, you got it, it's 24. She put half of her money into savings. That was easy peasy, which means that she has 24 remaining. And of that 24, I know that 3/4 of it she spent at the mall. So I just need to figure out how much 3/4 of 24 would be. I can find out how much is 1/4, which is 1/4 of 24, which would be 6. And then I would just add 3/4 of 24. So 3/4 of 24 is 6 plus 6 plus 6. So that's 18. And now I know how much she has left. She has 6. So Kat has $6 left. Awesome. And that makes sense. We can use a backwards approach, thinking 4 groups of 6 is 24. 24 is how much she had left after she put half, another 24, into savings. Our approach works. We can do it. All right. Now, maybe you're teaching 6th grade, and this approach can also work well with ratios. Go ahead, we'll read the problem and picture what it's about. And then we're going to rewrite the question into a sentence. The ratio of adults to children at the Halloween ball was 2 to 3. If there were 140 adults at the Halloween ball, how many children were there? All right, so let's go ahead and think about how we can rewrite the question into a sentence. There were blank children at the Halloween ball. Now we're going to determine who and what was involved. Again, this helps us determine what kind of bar model we're going to draw. So we have adults and children, and we're going to draw 2 separate bar models, one for adults and one for children. Now, we know that the ratio is 2 to 3, so we can go ahead and chunk the problem and adjust the unit bar and fill in our question mark. 2 adults for every 3 children. And we were also given the total number of adults. So if there were 140 adults, how many children were there? So we're trying to figure out how many children were there, and we are given the total for the 140. Since the ratio is 2 to 3, I know that 140 represents 2 of the total bar parts for our adults. Now I need to figure out how much would that be for our children. Remember, ratios are all about relationships. So we'll go ahead and compute and solve. 140 adults, 210 children. Because we know that 2 units equals 140. So 1 unit equals 140 divided by 2, which is 70. And that means each of the children units is 70. So 70 times 3 is 210. Awesome blossom. All right, let's talk about a bridge to algebra here. Jamie had 4 times as many candies than Angela. Kai had 12 less candies than Jamie. If the 3 kids had a total of 258 candies, how many candies did each kid have? Now, in a bridge to algebra, we can start writing this. And this is how we go from a concrete to a symbolic representation. So, Jamie, put the J here for Jamie, had 4 times as many as Angela. Don't know how much Angela had, so we'll just say it is X. And Kai had 12 less than Jamie. So if Jamie had 4X, if Jamie had 4X, then Kai had 4X minus 12. All right. Now the students can see this visual model and that this entire bar model represents 258. Oops. We can go ahead and write this as an algebraic expression, which would be 4x plus x plus another 4x minus 12. Then we can start talking about some strategies, like combining like terms. 4x plus x is 5x, plus another 4x would give me a total of 9x. And we're going to subtract 12. and that equals 258. All right. Now, the steps for solving a two-step equation would be first to add 12 to both sides of the equation because we want to get rid of the constant. So we'll add 12 because negative 12 plus 12 will cancel here. And 258 plus 12 will give us a total of 270. I'm just going to start it over here. 270. So now we have 9x equals 270. The second step of the equation is to divide both sides by 9. And 270 divided by 9. You got it. Equals 30. All right. We can go back and check and see how much each kid would have. So 30 times 4 is 120. X is 30. And then 120 minus 12 is 108. All right, friends, now that we've done that process, we can move on. And don't forget that this is building a bridge to algebra. So as you can see in this problem, using a bar model is a wonderful bridge to algebra. When students hit middle school, they will need to be able to transfer their thinking to an algebraic expression. And the bar model approach is a wonderful tool if either your students are stuck or they need a way to get started. So just like in this example, we drew a model and we then partitioned our model to represent each of the variables. Then our students can transfer that model to an algebraic expression. And hopefully you can see those important connections that kids are making and how the bar model approach is a wonderful bridge to algebra. Now, another thing is that you can always create your own problems. And this is another way to really engage your kiddos and get them hooked on what you're doing and excited about problem solving. Because as I say in my classroom, problem solving is every day of our lives. So we want to give our students the tools to think critically and a strategy to launch into problem solving. If your kids are stuck, you can always get them up, have them working and drawing on the board, as you can see on the left-hand side, or you can use another wonderful tool that I love, which is Google Jamboard. And again, if you subscribe to the channel, you'll also have access to this wonderful Jamboard. And I love this. I think it's a great way to support students who learn differently. You can add a sticky note with each of your steps. They can use the shape tool to draw your bar models. You can add cute images and a Bitmoji to contextualize it and get them to start step by step. What is the write a closed sentence, draw your bar model, chunk it, label it, etc. So these are all great ways to get your kids hooked and get them started. And in my class, I always like to have the kids a little early finishers to create their own slide in their problem and a way for them to launch into the process. All right, and remember that this approach builds on the National Council of Teacher Mathematics 5 representations. And this is from the principles of actions, and this is how we want to approach teaching mathematics. As you can see, the bar model does all of these 5 representations. We have our visual, and we could always use the physical, the contextual, especially if we're using those digital manipulatives, and it was provided context, get your students to explain their thinking, and then transferring it to the symbolic form. And fractions, I just want to emphasize that maybe you are already using bar models, but as we know that fraction predicts knowledge of algebra, so the more we can emphasize this approach, especially when we're working with fractions, the more likely students are to be successful in later high school mathematics. All right. And don't forget that it's the teacher that makes the difference, not the classroom. All of your students are capable and they're able to do this kind of mathematics. We just have to give them the tools and strategies to be successful. And hopefully you found this approach a wonderful way to really get your students to think critically and to approach problem solving in a way that is fun, engaging, and allows them to make sense. Thanks so much for all that you're doing. Don't forget that you can always join my YouTube channel and get all of these free goodies. I'm also on Amazon and I have a podcast. So I hope to see you soon. Leave a comment and let us know what you'd like to see next. Or just give me a shout out. What did you like about this video?